Okay, so you learned how to calculate a residual, what a residual was. But now, what's the importance of a residual? Okay, it starts with the calculator. What the calculator is doing when it is calculating this least squares regression line right here, okay, is it's taking each residual. Oops. It's squaring it, okay? So it's taking each of these residuals squared, and then it's finding the sum of those residuals squared. And it wants it to be the smallest sum possible in order to calculate the least squares regression line. Now, you don't need to know how to do this. You just need to know the idea behind it. Think of it this way. Here's our perfect regression line. We have here, it's red. But what if I would move it to right here instead? Look at those residuals now, you guys. Let me draw them for you. Now these residuals are pretty dang big. If I would take these residuals and square them, it is not going to be the smallest sum that is possible. That's what your calculator is doing. It is finding the residuals, squaring them, and calculating that line so the sum is as small as possible, the least squares regression line. Now, with our residuals, as statisticians, we like to look at the residual plot, and there's some importance for that, okay? It is important to look at the residual plot. But first, I want to show you how a residual plot is actually plotted. So I have some just simple data here. I have an explanatory variable and a response variable. And I put this X and Y into my calculator, into L1 and L2, and I calculated the least squares regression line. Then what I did next, so follow along, I took each value. So I took 0 and I plugged it into X, and that gave me 2. Then I took 1 and I plugged it into the X, and that gave me 5.1. And I continued to do that. That is giving me the predicted value. When I use this regression line for prediction and I use these values here, plugging it into X, that gives me the predicted value. Again, 0 into X, 2, 1 into X, 5.1, 2 into X, put it in that equation, right? 8.2, 3 into X, put it into the equation, 11.3, and finally 4 into X. The prediction is 14.4. Now I found my residual, my observed value minus my predicted value. And you see that here. And finally, you see my plot, okay? So I have my x-axis here and my y-axis here. You can see now when x is equal to 0, the residual is -1. So this coordinate point right here, 0, 1, means when, or -1, excuse me, when x was equal to 0, the residual is equal to -1. You can see it again when x is 1, right? The residual is 0.9. So you can see that I go on the x-axis to 1 up to approximately 0.9, and you can see the plot there. I continue when x is 2, the residual is -0.2. Plotted right there. I would have done it maybe a little bit under, but that's okay. 3, 1.7, so 3 up to 1.7. And then finally 4 over to -1.4. That is a residual plot. But why is a residual plot important? Well, let's look. We can tell a lot about a residual plot, about the data, and about the least squares regression line, okay? One of them is by looking at the plot. Now here is a residual plot, okay? You can see decent scatter, it kind of gets thinner, but we have this point way up here. This is an outlier in the y direction. How do I know that? Well, there's a lot of x's from here to about here, right? There's a lot of different x values. But this one has what we say a very large residual, because here is our x-axis, right? This is the explanatory variable. It's the value of that explanatory variable. And then here, the y-axis, okay? This y-axis here, well, that's our residual. So this point right here, right? This point is x, comma, whatever that residual is. And you can look and see that it is quite large compared to the other residuals, okay? Another thing you'll notice, it's a positive residual. It's positive here, negative down here. Okay, now, what does it mean that it's a positive residual? What does that mean? Remember, a positive residual means the line underpredicted. And you can see here in this graphic, they actually tell us what that point is. So it underpredicted the value of y by 30.284971. We don't know the units, but it's just important for you to be able to look at a residual plot and say, wow, this one's way up there, okay? That means it's an outlier in the y direction. Okay, now next, looking at another residual plot. Right here, we have an outlier in the x direction. Now the residual is not very large, okay? But this point has leverage, we say. You can see most of our x values go from here to here, okay? Again, this point right here, we're gonna cross this part off. This point has leverage. It is an outlier in the x direction, okay? It's an extreme x value. Individual points that are extreme in the x direction, these points are outliers in the horizontal x direction. Such points may not have large residuals, but they can be very important. What should we know? Recap so far. What should we feel good about? When the calculator is calculating that line, it's looking at the residuals, what the possible residuals will be. It's squaring them. It's finding the sum of those squares, and it wants it as small as possible. What else? We can look at a residual and we can determine outliers off of it. Outliers in the y direction or the x direction.